Hello, everyone. We're from Group 5, and today we're going to present our project, which is the heart rate sensor, or the heart rate monitor. And my name is Courage.
My name is Jordan.
And my name is Ray.
So our project is just a way to warn if your resting heart rate is high, and then it just sends the data to the cloud. It also displays your heart rate live on the OLED, and if your heart rate is normal, the green LED will light up, and if your heart rate is higher than normal, the red LED will light up, and the buzzer will make a sound. And when it's above normal, that's when the data automatically gets sent to the cloud.
And here's our actual components. I just took it from our PowerPoint.
So here we have the first part of the loop, where the code initializes the MAX30102 sensor and lets it measure BPM and average BPM. After that, it checks the Wi-Fi connection and then displays all that info onto the OLED display. In the next part, the code checks whether your heart rate is normal, aka between 40 to 95 BPM, or abnormal, aka 95 and above. If it's normal, a green LED will light up and it'll show on display that your BPM is healthy. If it's abnormal, a buzzer and a red LED will light up and it'll show on the display that your BPM is not normal. During the state where the BPM is not normal, this code is going to check whether it's been 15 seconds since you last sent your data onto the cloud and if Wi-Fi is connected. If both are true, the data will be sent onto the ThinkSpeak cloud platform. We're using the 15-second delay because honestly, we're using the free version of ThinkSpeak, thus it can only receive data every 15 seconds. You can also record your average BPM manually by pressing a button.
So here's the actual code in case it wasn't clear. We initialize everything first. This part, including the Wi-Fi, and outside of this code, we actually have some external functions, which is the check Wi-Fi, and these are like default templates, and we also have send number, which is also a template that I found online, but it's very useful for this project, so I can just use those functions to put in the main loop, and it just makes the code way easier and cleaner to read. But anyways, after initializing, it's the setup. That's when you initialize the pin modes, the components, and everything else, including the Wi-Fi. Anyways, here is the main loop, which we already explained with the flowchart. I don't care if you want to steal the API, we're not using it anymore.
So next we have the Wi-Fi part, or the cloud platform. So basically for the cloud platform, we connected our project, the ESP32, with Wi-Fi using Wi-Fi.h, the library. And then we set up a channel on ThinkSpeak, and we took the API from the channel and then selected a field that has a template to receive data and log its time automatically. It can even turn that data and time log into a nice line graph that can display trends and stuff. With that, the website and the API key are then written onto the code using a data sending template to finally connect our project onto the actual cloud itself. And then afterwards, here's a demonstration.
All right, so here for the demonstration, you can see that the Wi-Fi is online, and when I am putting my finger on it, you can see the reading, everything's updated live, the average BPM, the BPM, the Wi-Fi status. And if the Wi-Fi is on and you press the button, it'll send. And if the Wi-Fi is on and your heart rate is over 95, it'll send, as you can see in this example here. All right. Okay, so for the data that we received from this device, first we tested it for a couple hours during the creation phase of this device. And you can see when we pressed the button and when it was like automatically sent due to the threshold. Sometimes we lowered the threshold as well to test if the automatic data thing worked. But here's the data logging. And as expected, whatever. Okay, so here's when we actually tested it for real. We made a new API, new channel, and what we did was for a couple of minutes, someone, me, tested it out by putting my finger on it and just hyperventilating to get my heart rate up and to see if it would send. And as expected, it did send the data when it was above 95. And for the periods that it sent when it was below 95, that's when I pressed the button. So the project right now, it's still proof of concept sort of thing. It's not really safe in a real medical environment because of how finicky these sensors can get.
But we can still think of some future implementations for this device.
Perhaps there are ways for the circuit to be miniaturized. For example, integrating it into a PCB model, and perhaps we can even replace the sensor and use a much higher, like maybe like even a medical grade sensor. The nice thing about it is that if you can really like miniaturize it, it can be used in a day-to-day life scenario. And especially for people that might have cardiovascular problems, they can like go to the cloud platform and then they can observe the trends and peaks of their heart rate. And from there, they can sort of like make observations about their lifestyle, and perhaps they can evaluate their habits and improve their health.
Okay, and that's about it for our embedded systems project. Thank you all so much for listening to our presentation. And if you have any questions, ask Jesse.